few minutes of discussion and we'll let you go. We got a whole day tomorrow. So let's talk, let me just really briefly ask about a couple of the activities. So some of you did, hopefully, I guess some of you maybe didn't get to the compound pulley activity. Well, let's talk about that one. What did people find? There was, so the compound, the multiple pulley activity, you got to see mechanical advantage in action there. What did we find in that case? Did we find with those multiple pulleys, one of the things I asked some of the groups to do is see how far you had to pull for a given change in height of the basket. And so what kind of predictions did we have for that? We had a couple groups. By the number of strings.
Number of strings.
This is 4. So you got, so some people actually got 5 and some people got, who got 5? For the difference in distance of efficiency. And there's some other, did anybody find 4? Right, and I think that may have to do with precisely how, we'd have to go back and look at how you use strings. I think they're probably both correct. It depends on exactly how you strung your pulley. So, you know, again, part of the message to bring home from that is you're getting a lot easier effort for a given weight. We also had another group go over and try the 6 string pulley. What did you all find? The group that did that. You all did that.
We expected it to be 6 times. Or, help me out, Gord.
About 6 to 1. 6 to 1.
But it actually was only 4 to 1.
The mechanical event. We thought that so you actually measured you actually the force measure.
Right.
And you measured the weight of that force.
Right.
And then what did you measure?
With the spring scale, we measured how much.
So this is interesting. Theoretically, it should be 6. And you found it was
4.
Closer to 4.
So what do people think? Why did they not get the theoretical value?
Friction on it.
So you're
The different type of pulley, though, could you reduce that friction?
yeah. So the actual mechanical advantage you get from a pulley system like that is completely dependent on the quality of pulleys. You know, I think in that case it's more about the friction of the axle pulleys. So those are cheesy pulleys. They're not well oiled.
Well, that was my question. You were saying they're cheap and they're cheesy, but I was wondering what really is the problem with the You said they need to be oiled better.
I think if they were oiled, you probably would see that mechanical advantage. I'm not sure it would probably go 6. There's also like they're plastic and they're moving around, you know, and they're not solid. Any other comments on the pulleys? People have questions about pulleys and mechanical advantage of pulleys. The other activity folks got some pretty good results with was the inclined plane. Very simple activity. I think in some ways the time you spent building the ramps maybe could have been, we should think about whether that makes sense. But I saw folks get some really good results from that. What did we find in the inclined plane? So there's sort of 3 different force measurements to be made there. There's the dead weight, there's the force it takes to pull up a steep ramp, and the force to pull up a shallow ramp, or a lesson. What do we find? So where do we expect to find the most force?
Vertical. Pulley at vertical.
Right. So the dead weight, then the dead weight's the most, right? Then steep ramp and shallow ramp. Does everybody agree with that? So that's actually a pretty cool activity. You know, the other way you can get that to be more perfect, or you can get it closer, because friction also plays a role in that activity. Friction's going to give you less of the ideal mechanical advantage. But you can do that same activity with a rolling cart. In other words, you can really reduce friction dramatically with a rolling cart, so you can actually have you can measure the force to pull the rolling cart up. Any other questions people have? What did people find with the well? Does anybody want to give us a synopsis of the results with the well experiment?
It was difficult to make some.
Well, this actually brings up an important point that we were actually talking about in terms of inspiring you to use these materials. The question we were kind of debating amongst ourselves was, do you think, there's specific concepts you want to get across in these activities, right? You have to do with some of the physics and civil machines. Is the building of the structure worth the time in these cases?
Yes.
In some cases.
In some cases. For example, my guess would be, in the case of the ramp, no.
Yeah.
Right? Yeah.
But the thing is that you're going beyond, I just differ in opinion because we've had a lot of discussions about our children and a huge inability to be problem solvers and problem-based thinkers. And these activities, while they do address science goals, they teach children how to think independently. And so there is huge value to allowing them to put those things together.
People taking shortcuts.
But if you're short on time, I still can't put them together, but I can understand the physics behind the thing, but my mind doesn't work to look at the diagrams and the colors and put it all together.
Right.
The other thing is we changed our model. There was a wide side and short side, and when we placed it on the base, we built those two components separately. So you're learning how to adapt the model to make it work without throwing in the towel on the whole thing. When you keep trying adds to this good aspect.
Yeah, I mean, this is your much more your area of expertise than mine. This is something I was curious about, and I guess what I hear you say is that it kind of depends on what you're trying to achieve with the activity. If you really want to get into physics, maybe you have a model built. But if you're also you want them to beat their heads against something and walk through some problems, it can be kind of hitting two different ideas at the same time. Any other comments before we let you go? We'll let you go a little early. So tomorrow is going to be more. We've got a bunch of really cool kits over here, solar model kits that we're going to have you all do. Jennifer, do we want to talk to them a little bit about what's happening tomorrow? Or they're tired and like.
They're tired.
But basically tomorrow we are going to actually ask